All right, good afternoon, everybody. If you can hear me, just say good afternoon in the chat. We're going to begin shortly. So I'm just checking the chat. I'm also checking to see who is here with us at the moment. Okay. Checking the chat, checking the chat. Today is the 15th. Okay, also let me know if you guys are seeing my screen, which should have a lot of formulas. Today we're going to be focusing on question number 6, which is the measurement question. As we know, that's one of the most challenging questions, not because it's really hard, but it's because of the nature of the questions and the formulas that are necessary, right? So what we're going to do first is we're going to examine the formulas that come in the exam and the ones that do not. So we take note of the ones that you should memorize and the ones that you don't have to memorize. In addition to that, I think this is the exact notes I sent everyone. So this is what everybody should have already, right? If there's anyone who don't have it and want me to send it to you, you could just send me a message and I'll send it to you via WhatsApp. So we're gonna get started in about 2 more minutes. So what I need you guys to do is head up your books. Good afternoon. Head up your books, head up question number 6, because this would be the first time we would be going through question number 6, okay? And question number 6 again is the measurement question. So once you finish, head up and make sure you have the date. Today's Monday the 15th. Just say ready. And once majority of persons say ready, I'll get started. That's no problem. Once you're tuned in and looking on, that should be okay. So that's 3 persons who said that they're ready, waiting for others to indicate that they are. Hoping that more persons come to class because this class is extremely important. Very, very, very important. All right, so let's get started. So like I said before, what we're going to do first is examine the formula sheet that you get inside the exam, right? If you notice, literally majority of this formula sheet is measurement. So when it comes to measurement, you know, you're talking about area, perimeter, volume of different 2D and 3D shapes. And the thing that makes this question difficult is that it's not a regular shape. It's always some kind of real life situation that you have to understand the context so that you can answer it, okay? So let's take a look. So like I said, the first set of formulas is literally all in relation to measurement. So let me zoom out so you can get an idea. This is the formula sheet again, exams. So everything from here to here is measurement, right? Then here is algebra, because you know what the roots of quadratic equations mean. This is the quadratic formula when you're finding the values of x is equal to this or x is equal to that when you're solving a quadratic equation. Everybody with me, right? I just want to make sure we're on the same page because all of us should know this, right? Talk to me, talk to me, talk to me. Yes or no? We should know these things. So even though we're doing another topic, we still got to be on par with everything else. We organizing the content in our brain. right? Okay. And then from here to here, we know that this is trigonometry. So you know sine, cos, tan. And then we would have done this one before when I would have taught y'all the different ways to find the area of a triangle. So to be honest, this, once you see area, this is also a part of measurement because there are three different ways to find the area of any triangle. The one that we know is the one that is half base times height. That's one. Then the second one is whenever you have a triangle that does not give you the height, but gives you the angle between the two sides A and B. So you see how this is angle C, and you have side A and side B, and angle C is in between. This is when you use the second formula. Keeping it in mind, what's the difference between the first and the second formula? The first formula, they give you the height of the triangle. The second formula, you have two sides and the angle. So you use the second formula. And then the third formula, which is this one here, it has two parts. You must find S to use the formula, and here they explain how to find S. And this is when you have three sides. So my question to you is, do you guys want us to write out these three formulas and highlight when to use each one specifically? You want me to do that? So y'all can have it in your notes? Okay, so let's break down the first one. And I think we did a class where we used all three, no? I remember we had a class where we used all three. But let's just make sure we understand. So the first one, let me zoom in so you could see properly. So the first one, this is what you're gonna write for me. You're gonna write area of a triangle is half base times height. That's the first one. And you're gonna write use when given the height of the triangle. So when you finish the first one, let me know, please. So for those who join in late, what we're doing is that we're going through the formula sheet that is given to you when you open the exam. When you open the exam, that's the first thing you're going to see. So it's important that you already know what is there and you know what is not there. Because that way you know what you need to memorize and what you don't need to memorize, okay? So what we're doing right now is highlighting the three different ways to find the areas of a triangle, because each one of them, you have to use them at different situations or under different conditions. So when you're done the first one, just say done. So this is the one everybody learned from first form primary school, half base times height. And you use when given the height of the triangle and the base, of course. So that's two persons done, just waiting for more persons to let me know when they finish. Or watching the chat, or watching the chat. I want to make sure we all on the same page. So if you finish writing, just say done, please. Thank you. Okay. All right, so let's go. The second formula now, this one is half AB sine C. And what you're going to do for me is next to it, you're going to write use when given two sides and angle between sides. I should put and the angle between the two sides. And the angle between the two sides. So as I was saying before, one, we using the height. But this one, we're using the angles between, this one is given two sides, which is the A and the B, and the angle between the two sides, which is C. Again, once you finish copy down the second one, you just say done. No problem, Janella. How we looking, everybody else? How we looking? Almost finished? All right. Excellent. And the last one, which is this one, uses the S, and S has a value. S is whenever you find the answer, when you add all three sides of the triangle and you divide that number by 2. So the condition for the third formula is you only given, use when given, use, let me use green because that's the color I was using for the explanation. You use if, or when given, I should say, sorry. Use when given 3 sides only. So for those who just joined, we are assessing the 3 formulas used for finding the area of a triangle. Each formula is specifically under a specific condition. And what we're doing today is we're focusing on question number 6, which is measurement. So for those who are in my class, this is the first time we're going to be looking at actual CXC questions under this topic. So what we're doing first is making sure everybody is familiar with all the formulas and understand when to use the formulas and how to use the formulas. Okay? So just to recap quickly, these 3 formulas is the same thing, the area of a triangle. The first one is if they give you the height and the base. So that's the one that we know, half base times height. The second formula is if they give you 2 sides and an angle, that means there is no height. And keep in mind, side C is not the height. The height is always perpendicular from the base. And you should know that the word perpendicular means what? At a 90 degree from the base. That is the height. And this concept is for every shape. Height must always be perpendicular from the base. Okay? All right. And then the last formula is used if they give you 3 sides of the triangle. That means no angle, no height. You only got the length of the 3 sides. That is when you use that formula there. So I want everybody to tell me if they got it, if they understand the difference between the 3. Just say got it if you do. Again, you don't have to memorize any of these formulas because it will be given to you in the exam on your formula sheet. So what we're going to do is just assess which formulas are given to us. The volume of a prism, and everybody should know what a prism is. A prism is a shape that is 3D that is consistent throughout. It has a face, and if you were to cut that shape in half, the face would look just the same in the center or anywhere throughout the shape. That's what we call a prism. It only has straight edges. And what we call the face is the cross section. These are things everybody should have heard already and should know. All right. So what they're saying is the volume, this is something that I want everybody to pay attention to. You see this formula here? This formula here generally goes for every 3D shape. You take the area of the face and you multiply it by the height. And when I say height, I want to show you something that has confused students all the time in the exam. Let's take a cylinder. Everybody know what a cylinder look like, right? If you have a toilet paper roll, that's how generally a cylinder looks. Okay, so let me just draw something quickly. Like I said, this is a concept that confuses students all the time. So here we have the cylinder. Let's pretend it look good, right? Let's pretend it look good. Yeah. All right. So let's take the same cylinder and give it another orientation. And when I say orientation, means like put it to rest in a different position. All right, so I'm gonna put some lines and I want you to tell me what line you think would match, which ones you will consider the height. So we have this line, we have this line, we have the same shape. Because I want to show you guys something when it comes to the different definitions of the height of a shape. All right, y'all ready? Let's call this A. Let's call this A. Let's call this B. Let's call this M. Let's call this P. All right, so if you guys ready for me to go through this concept, just say ready, please. All right, let's look at the first shape, which is the same shape, but just that it's standing up. Which letter do you think represents the height of the shape in this position? Excellent, I agree. This is the height of the shape. This would be what we would call the width of the face. And at this moment, what shape is the face or the cross section? What shape is this? A circle. So we need to pay attention to this, right? Because watch this. This circle is a shape within the larger shape. So if they ask you to find something, whether the volume or the area, you have to be careful about which height they're talking about, which width they're talking about, which length they're talking about. Everybody understand what I'm saying? Because, for example, some people, let's don't even talk about height. Let's talk about length and width. Some people would say this would be the length because they go left to right. And some people would say this would be the width. To be honest, it doesn't matter once you understand what exactly you're calculating. Okay? Are you calculating the area of the face or are you calculating the volume of the shape? That means the height would then change based on what you're actually looking for. Everybody catch what I'm trying to say? I hope y'all kind of understand where I'm coming from, right? Let's look at the second shape. Which one would be the height of the shape now? M or the P? We're looking at this one here. The M or the P, which one is the height? All right, I'm waiting for more people to try so that I could explain. That's why I'm asking. So talk to me, talk to me. Which one is the height of the shape? Ladies and gentlemen, guess what? The height is M. You know why? Not because it lying down. Remember, this is a 3D shape. You look at where the face is. Remember, the face is the base, right or wrong? And the height is how far long the base runs. Everybody see what's going on? So if you were to find the volume of this, the volume would be the area of A times B, which is the height. Look at shape 2. What is the volume? Volume is equal to area of the face times the height of the shape. What is the area of the face? The face is again the circle. Here, the circle is to the top and to the bottom. Everybody understand the definition of height of an overall shape now? Even though the shape is lying down, by definition, height is how long the shape runs against its face or bottom. If you got it, say got it. If you don't got it, say don't got it. I need to know now so I could know if I need to use another example. Talk to me. So I just addressed something that is throw students off and get his question wrong. That simple concept. Imagine you use the right formula, you know what you was doing, but because your concept of height is wrong, you get a question wrong. So let's use another example then. Okay. Tell me, what shape is this? Give me a minute. I'm trying to think. I hope y'all understand the shapes I'm trying to draw. So I hope everybody paying attention. Because again, CXC now brings question that requires understanding of perception. And when I say perception, I mean how things look, how things are given, how things are drawn. Okay. Everybody talk to me. What shape is this? What we call this? Everybody agree, right? Is this a prism? Based on what I describe a prism is at the beginning of class, is this a prism? Yes or no? Even if you're not sure, you need to make a decision. We got 3 more weeks until exams. You got to start forcing yourself to answer things, even if you don't feel confident. You have to try. So I've seen some yes, I've seen some yes. Excellent. Just for those who may not be sure why. Everybody see the face of this? The front? You could tell the difference with the front and the side, innit? The front would be this area here. Do you agree? Of the prism. So if I were to cut this shape right here, like slice it through, maybe I should cut it in a different direction, like maybe here like this. Yeah. If I was to cut this shape just like that, aren't we going to see the same face when we move the front part away? If I slice it down, let's pretend this slice look good. I don't even know again how I slice. But yeah, let's say I slice it up just like that. What are we going to see? Aren't we going to see the same face inside there? It's okay. You got a loaf of bread. When you cut the bread, all the slices essentially have the exact same face. What do we call the face again? The cross section. So now, suppose somebody say, fine, I'm going to give each thing a dimension. So from here to here, let's call this A. From here to here, let's call that B. Going back, let's call that C. Okay, everybody understand how I label each thing? So left to right is A, up and down is B, and this line going backwards is C. Now, because we're looking at volume, which dimensions we should be talking about? We should be talking about length, width, and height. Do you agree? Come on, people, talk to me if you agree. Okay, suppose though, I only want to talk about the face. Which 2 letters should we focus on if we're talking about the face only? Type it in the chat. Which letters, it could be 2, 3, I don't know. Which letters would we be focusing on if I looking at the face only? Denaya said A and B. Alicia said A and B. Somebody said A and C. Keeping in mind, look at the face. Look at the face. Watch where the face is. What 2 lines does deal with the face only? Ain't just the A and the B. Okay. But you see this? Would the exam would the exam do that? I see what you're saying, but the exam not gonna do that for you. So you have to learn how to see it. If you check what I'm saying. For the purpose of explanation, I would do it now, but in the exam, that's not how the question is gonna come. Everything gonna be in black. So I'm gonna highlight this. So this would be B in yellow. Let's do C in what? Give me another color. Black. Let's do C in black. I'm only doing this now. I don't want I gain this habit of expecting quality coordination because that's not going to come in the exam. But as I was saying, the front of the shape only requires you to use A and B. Would you card be the height of the face based on how it positioned? Talk to me. Yes. So you see here, B, based on what we're focusing on, we ain't focusing on the overall shape, we're focusing on the face. And because we're focusing on the face, under these conditions, B can be defined as the height. So everybody understand now? No, look at the overall shape. Doesn't this overall shape look like it lying down flat? Suppose I were to take this same shape and make it stand up. What letter would now represent the height of the overall shape? Which letter would represent the height of the overall shape now? Excellent job, everybody. It will be C. Because remember now, we're working outside of the entire shape. The entire shape is now in relation to where the face is located. So if this is my face, and then you know coming down here, you got a base as well. So I'm just sketch it there so you can see. Remember, we know how this thing go, right? This would be the base. So obviously you got the top and the bottom. And so C would represent the height. So everybody understand what I was explaining when it comes to how a shape is positioned? You have to see if it's lying down, if it's standing up, if it's a prism. Talk to me. If you got it, say got it. Okay, so I hope this helps us as we get into the exam questions. I'm waiting to see more people like share if they understand the whole concept of where the actual height of the shape is. All right, so let's move into the other formulas that we are given. So we get volume of prism, volume of a cylinder, volume of a right pyramid. We get the circumference of a circle. Keeping in mind, we did this already. 2 pi d is the same thing as pi d, 2 pi r, sorry. Why? Because you know the diameter of a circle is the same thing as having 2 radius, which is 2r. Just to draw it so you could see, remember the diameter goes straight to the center and the middle point. So this would be a radius here, and this would be a radius here, and both of them going straight across is what gives us our diameter. So 2 radius is equal to 1 diameter. All right. Arc length. Everybody know what's an arc? That's all I want to know. Yes or no? Do you know what the arc is? When they talk about arc, the length of the arc, what do you know what that means? You know what's so crazy about this? We did circle theorems and we did all the parts of a circle. If you don't know it, I mean you're not revising enough. That means that's not good enough. The arc is just a section of the circle. So if I cut the circumference from here to here, I will call this the minor arc. So from here to here is what we call the minor arc. And the other piece, which is the larger piece of the circumference, is what we will call the major arc. So minor, major, that's what they call the arc. Piece or section of the circumference. And that is why, look at this. You realize the area for the length of the arc, sorry, is a fraction of the area of the length of the arc. Look at that. Circumference is 2 pi r, and now the length of the arc is just a fraction of that. Anybody could tell me why they put everything over 360 for this? Where they use 360? Where that number come from? What is 360 affiliated with? What shape is 360 affiliated with? Excellent. Is a circle, right? All the angles in a circle add up to 360. So let me explain again quickly. If I have a circle and I cut from here to here, this entire circle is 360, but if I say here is 60 degrees, this 60 degrees ain't representing this piece here from here to here. Everybody see that? So what they're saying is that if you want to find out this piece here, first you find out the length of the entire circumference, and then you find the fraction of it. And what would the fraction be? The fraction would be 60 degrees out of the total, which is 360 degrees, times the overall circumference, which is what? 2 pi r? 2 pi r. Everybody, what's the value of pi? What is the value of pi right now? Because you realize they don't give you that in the exam. You have to know it out your head. That's one person. What is the value to 3 dps? I teach how to 3 dps. 3.14. Thank you. 3.142. Yes. No, there's a fraction version of this. Anybody know the fraction version of this? The fraction version is 22/7. If you know you don't have that, copy it down now. So pi has two versions, a decimal version and a fraction version. All right. So moving on, you should know what a sector is. A sector is what we call a slice. So if I cut a slice of cake, the small cake is what we call the minor sector, and the bigger part is the major sector. So the area of a sector, you just literally find the area of the overall circle, and then the same thing that you did for the length of the arc, you use the fraction to find it. Trapezium, everybody should know how a trapezium looks. It has one pair of parallel lines, and it's a quadrilateral. So this is how a trapezium generally looks. You got different versions, eh? You got ones that look like that. Once you got the pair of parallel sides, you know, that's your trapezium. Keeping in mind times the height. The height is the distance between, the perpendicular distance between the two parallel sides. So that's what you would have. And that's basically all the formulas given. Okay, I'm just going to run through formulas that you should know out your head. So we're going to do the first page, and you're going to tell me out to the 8 how much you know already. If you're ready, say ready, let's go. We have here 23%. All right, so we're moving through this quickly because we need to focus right into the questions, which I need us to do by 6 o'clock. Okay? All right, so first one, square. Properties of a square. Please don't look at the picture. This is a perfect example of not drawn to scale. And you should know what not drawn to scale means. The picture does not represent the data correctly. It off. So you can't watch a shape and say, oh, that don't look like a square. If they give you dimensions that say it is a square, it is a square. So first one, length and length. That means both of these sides are equal. Therefore, it's a square. Length is equal to base. You see some people just use base and not width. That's fine. What is most important here? The area of a square gonna always be a square number. So if this is 5, that is 5. The area is going to be 25 because 5 times 5 is 25. So that is why they have L square. The perimeter is 4 times L. Why? All of the sides of a square are what? Equal. Another property of a square that you should know is that all of the angles in a square is also 90 degrees. So all of the angles are 90, all of the sides are equal. Moving on. A rectangle. The properties of a rectangle are a bit different. Why? They have 2 pairs of equal sides. All of the sides are not equal. The length and the width are not equal. So the area formula is same thing as a square, length times base, but the length and base is different. So that is why you would have that. Perimeter, they say 2 times LB. Why they do that? You don't have to follow this, eh? But why is it possible to do that? Because there are two lengths that are the same. So that's why you could say 2 times length plus 2 times width or 2 times base. Moving along. This is where we get real serious because this is something that you need to know. The parallelogram. What makes a shape a parallelogram? They must have 2 pairs of parallel sides. So listen to this question. Is a square a parallelogram? Based on my definition just now, a parallelogram is a shape that has 2 pairs, is a quadrilateral. Let me correct myself, it's specific. A quadrilateral with 2 pairs of equal sides going in the same direction. Is a square parallelogram? I'm watching the chat. Excellent. It is. Is a rectangle a parallelogram? Yes, it is. These 2 sides are parallel. These 2 sides are parallel. Is a parallelogram a square? Is a parallelogram a square? No, because what is special about a square? All the sides must be equal, right? Please pay attention to these things because these are the questions CXC does bring to throw people off. Weird, 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 weird. They're gonna ask you why, and you should know why, right? No, we got some formulas here. Like I said, my students should have this formula sheet written in their books already. So it's just for you to make sure you understand how to use them. We have several formulas for the area of a parallelogram. And please pay attention because you see this version here is when CXC is moving savage and they're going to give you the regular formula. They're going to give you the formula. Well, they're going to expect you to use the formula that's more advanced. So the first one, we're paying attention. To find the area of a parallelogram, it's not A times B. It's not like the regular square and rectangle. Why not? Because it's slanted. So it must be the base times the height. I explain what height is. Height is the perpendicular distance from the base upward. Everybody with me? So area, that's the first formula, is base times height. No, remember, just like the triangle, there are cases where they don't give you the height, but they give you the angle between the 2 sides. It's the exact same thing. So the second formula, area, is when you have A times B, because remember that's the only thing they gave you, the 2 sides, and the angle between, and we should all know that this little egg thing is the symbol for what? What an egg thing represents? Somebody, anybody? What does that egg symbol represent? When you see that, what does it mean? The name is theta. Yeah, answer Peter. The name is theta, but the symbol represents angles. Thank you so much. Closer, better than nothing, right? So, like I was saying, the second formula, you multiply the 2 sides and then you sine the angle in between. Anybody could remember what has happened when you sine a number? If I sine 60, what type of number I must get? Anytime you cos sine tan a whole number, you must get what? A decimal. These are the things you should know, you should be expecting. So if you plug it in your computer, not your computer, your calculator, and you see something off, you know that's not right. Check it again, do it again. All right, same thing. Perimeter is easy, right? Perimeter is just the distance all around. So you know these 2 sides are equal and these 2 opposite sides are equal, so that's why they do that. You see how they explain this? Height is the vertical height, which is the altitude. So these are words you need to know in case you see CXC use it. You know, altitude is another word for height. Please write this down if you don't have it already, because this is important. This is what we call verbiage. These are the different words CXC could use to represent the same word, height. If you got it already, or you're writing it down and you're writing it now, just say got it, please. Put it in a box. When you copy it down in your book, just put it in a box. I have a question. Anybody hearing a lot of dogs barking from my end? Y'all hearing it? Okay. Okay, I'm just making sure because all the dogs in my neighborhood going crazy. I may know why. All right, y'all ready? Y'all finish? So we can move on? Everybody checking in, talk to me. Are you finished? Copying down. Are you ready to move on? Okay. All right. I hope everybody okay. I hope everybody calm and focused because question 6 is a question that generally students don't even bother try, to be honest with you. This be a mess. All right, so let's move on. This is a rhombus. No, does it look like a rhombus to you? If you know what a rhombus is. A rhombus is the leaning version of a square. When you look at that, does all the sides look equal to you? I asked a question, only 2 persons responded. Let me take this opportunity to remind you guys, all I just ask of you guys is to respond to questions, right? That's all. I doing most of the work, so that's the least you could do for me, please. Thank you. Don't violate the thing. So when I ask a question, I expect to see a ripple effect of yeses and nos coming through the chat. All right. So let's keep it moving. Here, we don't do this one already, right? Everybody remember the 3 formulas? Half base times height, half AB sin theta, and then the one with the S formula. We did all 3 already, so I don't need to go over this. For those who came late, we did this already at the beginning of class. These are the 3 different formulas that you use to find the area of a triangle under the 3 different conditions. I'm going to say it one more time. The first one is if they give you the height. So you know this one already, half base times height. The second one is if they don't give you the height, they give you 2 sides and the angle between the 2 sides, that's the formula you use. And the third one is if they give you no height and no angle, but they give you the length of all 3 sides. You find S. S is when you add up A, B, and C, which is the sides, and you divide that by 2, and then you just work out the formula, okay? Now, this is a kite. A kite is another quadrilateral, and you should know what a diagonal is, right? A diagonal is when you take one opposite end of the quadrilateral and connect it to the other. So you have 2 diagonals, the longer one and the shorter one. The area is half the product, because you should know D1 and D2 really means D1 times D2, right? Half of the product of the 2 diagonals. Has nothing to do with the sides. Then here we have our trapezium, which we spoke about before. It is half A plus B. And what is A plus B? A and B are the parallel sides. So you add the parallel sides, you half it, and then you multiply it by the perpendicular height or the distance between the 2. Then we have the circle, which is easy. Pi r square. How do you know the difference between these 2? You know, people is getting confused. You should not, because the formula is in the formula sheet. So please take time, go back to the front if you don't remember which one is which, if you can't memorize it. So how much formulas we had here? Let's see. So the first page was 2, 4, 6, 8. How y'all feeling out of 8? 8 out of 8, you understand all 8? 5 out of 8, 6 out of 8. I need people to tell me as quick as possible so we can move on. 6 out of 8, okay. Please write down the ones that you don't know. Because when we have class again, I'm going to ask which one so I could go over it, okay? So the ones that you don't understand, write them down now. I'm also waiting for other people to tell me which What is their score out of the 8? I'm watching. And these are the easier versions. That's why I ask, because you need to know them. You need to know them. You need to memorize. Which ones you don't need to memorize, I'm going to draw a line. You don't need to memorize that. That's on the formula sheet. You don't need to memorize that. That's formula sheet. This is formula sheet. This is not formula sheet. The kite is not there. The parallelogram is not there. Was the square there? I don't think the square there. The rectangle was in there and the rhombus was in there. All right, so let's move on. Ooh, I have to erase all of this so I could start from scratch. Okay, because I know I taught this already. That's all I know. All right, so be zooming in on these two concepts. All right, so everybody should know the difference between a sector and a segment. If you don't remember, this is your revision quickly. Remember, the sector is like the slice, and the segment is created by what? What do we call this line here? Let me just highlight it quickly. What do I call that green line? Thank you very much. It's called a chord, right? A chord is what creates the segment into a minor and a major. What these two lines are called here in the first diagram. What do I call this? It literally got the letter that represents what it's called. What is this called? What a line called? The radius. Thank you. So 2 radius creates what we call our sector. So keep in mind, sector is the slice, segment is the piece, a bigger piece, the piece that's not the slice. All right. Now, what I need you to pay attention to is to get or calculate the segment, do you notice that you must get the sector first? Look at it. How do I get the segment? If I take a card and I add it here, that ain't how I create the segment. Let's start right there first. Everybody see how that was created? Yes or no? Because I can't go through the other part if you don't understand that part. That's one person. 2. I was explaining how do we create the segment from a sector. So look at the shaded areas, right? Everybody watching the shaded areas? This shaded area is what we call a sector, and this shaded area is what we call a segment. And what I'm saying is how both of them are connected. For you to get the segment, you must start off with the sector. You're going to take a card and draw a card, and that is what creates the segment. Do you see it? Look at it. It's the same exact drawing. Yeah? All right. So let's focus on the sector first. We know how to find the area of a sector. Luckily for you, this is given in the exam. This formula is given to you in the exam, so you don't have to memorize it. This is also given to you in the exam, the arc length, and I explained this already as well. Remember, the arc length is the piece of the circumference, so that will be from here to here. So before I continue, please let me know if you got it, the first two, if you got it and understand what both of them talking about. If you came to class late, you would have missed that part, so don't stress yourself too much. But for those who were here, let me know if you understand the 2 formulas used to find the area of the sector, which is the slice, and the length of the arc. Now, this is the tricky part. Let me explain. I want to take some time to make sure I highlight this. You see this part here? This is the part that has come for exams that no students don't do. Everybody, it's easy to find the area of the sector. It's easy to find the length of the arc. But guess what's hard? The perimeter. First thing first, how many sides are there to the sector? How much sides you got in all? Wouldn't this be one side? And that would be a radius. Let's go slow. I want everybody to let me know yes or no, if you're with me. So we're talking about this side here. Side one. We're going to call it side one. Okay. We're going to call over here side two. And wouldn't this also be the radius? Remember, perimeter is the distance all the way around, right? The sum of the sides. So the last side now, wouldn't it be this piece of the length of the arc? So it's three things you need to get the perimeter of a sector. The two radius, which is this part here, and the arc length. And we know how to find the arc length because the formula is in the formula sheet. So for those who are late, I'm going to just go back quickly just to show you what we're talking about with the formula sheet. We're gone. This is the formula sheet that comes in the exam. Those formulas are given to you here. Sorry, so you don't have to stress yourself about memorizing it. You just got to remember how to use it, okay? So let's get back to what we're talking about now. So as I was saying, everybody understand how to find the perimeter now? It's just, do not, let's seriously stress you. Keep focus. Remember what a sector is. Look at what makes up the sector. And if they ask you about the perimeter, you know it's two radius or two radii and the length of the arc. If you got it, say got it. Okay, all right, let's keep it moving. Next one now. This one is a little bit more complicated. So let's first focus on the segment. What makes the segment? Like I said before, the segment is just a section of the sector. It's like the bottom half of the sector. So how do I find the area of this if it does come? What do you think you have to start off by finding? You would have to start off by finding the entire sector first, right or wrong? And we know how to do that because they gave us that formula. That formula is given to you in the exam formula sheet. Now, when you split it with the card, what you should notice is that a triangle is formed, right or wrong? And do we have the height of that triangle? No, we do not. But we have two sides and the angle between those two sides. And we know that that's a formula that we know because that's the second formula for the area of a triangle. So what they are saying, right? If you want to find the area of this shaded area, find the area of the entire shape and just subtract the triangle. If you take this part away, what is left wouldn't just be the segment. Let me know if you see it, please. All I want to do is just make sure you see it and you understand what you're looking at. The calculations is the easiest part. So let me know if you see it. Do you see it? If it's no, it's no, eh? Talk to me. You want the shaded area, and I'm watching the chat. And again, I'm watching the chat and I need communication. You want the shaded area. The shaded area is a piece of the entire segment. What they're saying, start off by finding the area of the entire segment. That's all of this here. Find the area of all of this first. Then find the area of the triangle. We could find the area of a triangle because we know the formula when they don't give you the height. You have two sides and the angle between the two sides. So that's this formula here, which we discussed already. So the area of the segment, which is this part here, the shaded area, is the area of the entire thing minus, take out the triangle. What is left back is what you call your segment. This formula is on your formula sheet. This formula is on your formula sheet. All you got to do is subtract. Moving on. Here we have some diagrams of some 3D shapes. Keep in mind what makes a 3D shape. You must have three things to measure: the length, the width, the height. So if I want to find the volume of this, all the volumes for general shapes are the same. Volume is equal to the area of the cross section And what is the cross section again? The face of the shape times the height. So remember, the height is the length. And remember, we spoke about this. Height, even though they're saying length here, this really represents height as well. Same thing here, height as well. Same thing here, height as well. So you find the area of this part, you multiply it by that, and that's how you find your volume. Everybody with me? If you're with me, say with you. So we could move on to some actual questions and practice. So let's go, let's go, let's go, let's go. All of this is things you just need to know and understand. Now, what has happened recently is this concept called surface area. Have you done surface area before? All I need you to know is yes or no. Surface area. Surface area. Okay, I wish I could hold this box in my hand, right? All right. When you talk about surface area, it's like, everybody see my little hand on the screen? You seen it, right? I'm gonna go through it, of course, I'm gonna go through it right now. Okay, let's pretend this is my real hand and this box is in my hand. Surface area is literally what it sounds like. You got a 3D shape, it got some surfaces. How many surfaces does this shape have? Even though you're only seeing a few, how many surfaces does it have in all? Excellent. Excellent. Each face has an area. So what they're saying is that the surface area is just the total areas of all the face. So that means I got to find the area of the front, but what do we know about the front and the back? The front and the back would be the what? Exact same, right? So the formula for surface area for this, total surface area, would be 2 times the front. And why do I say 2 times the front? Because that represents the front and the back. Let me know if you're with me. Everybody with me? Plus, what shape we seeing? 2 times the top. Because what would 2 times the top represent? It would represent the top and the bottom. Plus the area of what we're seeing right now. We're seeing the right-hand side. So 2 times the right-hand side. But we know, what does that actually represent? That represents the right and the left-hand side. Everybody with me? When it comes to total surface area, that's easy for a cuboid, because why is it easy for a cuboid? Each face is the same shape. Each face is just a rectangle. So what formulas you're gonna be using? You're gonna just be using the length times width formula. Yeah? So that's easy to find the total surface area for a cuboid. The sum of the areas of all 6 faces. Now, this here is where things get real. Let's imagine if I had a toilet paper roll. Again, you know how the toilet paper roll look. It looks like a circle to the top and the bottom and a curved area, because we all know this curving, right? But anybody ever cut open, if you was to cut open the toilet paper, anybody could imagine what shape you would get if you cut it open? Do you know, if you cut open a toilet paper roll, this is how we're gonna look? What shape is that? Well, let's pretend it look good, right? What shape is that? It is a rectangle. And then what you would end up with is like a circle here and a circle here. Because this circle would represent the top, this circle would represent the bottom, and then this here would represent this material here in the center. Everybody with me? So guess what they did? That's why they have this. They have 2 pi RH. Because, let me explain why. This part would represent, let me show you, the curved area, which is the circumference, which would end up becoming our length times our height, plus 2 pi r. And you should know pi r square is the area of a circle. And how much circles you got? In 2 circles. The top and the bottom. Everybody with me? So it's all about perspective, right? I haven't seen them bring any surface area in a while, but I just wanted to make sure you have it. Now, this one now, they don't give us. Make sure you have this copy down, please. The sphere. A sphere is like a basketball, a volleyball, a football, a cricket ball. They like to bring sporting stuff. So this is something you must memorize. How do I find the volume of a sphere? 4/3 pi r cubed. You know what has helped us? Volume is cube, area is square. That's the difference, all right? And then you have 4 pi r squared. So let me know when y'all finish copying down those two formulas, or if you have it already, say done. So that what time it is? It's 6 o'clock now. Let's see if we can hurry up and move into the questions. Yeah, most people, like I said, people from my class should have them already. So it's for persons who are not in my class to either screenshot it or take a picture so they could have it. But I hope everybody feeling a little bit more comfortable with the formulas that you have already. So these are the last set of formulas, and then we're going straight into these questions. And let me explain to you why these questions are important. CXC got a pattern of bringing questions in 1 or 2 categories. Once we go through all of these questions, we would have touched every version of question that has come from CXC, right? Which would include a cone type question, a cylinder type question, a weird shape type question, and they usually follow the same patterns, but just in different ways. So what we focusing on is understanding how the questions just come. Everybody with me? Okay, so let's go. So these are the last 2 formulas, and then we're going straight into the past paper questions with the solutions. All right, so here we have a cone. This cone formula here got a cone formula came for the exam. Let me see. No, they did not. So let me tell you no. They like a cone, sexy like a cone. I don't know what's going on with them in cones, but they love a cone. Please memorize this formula here. Very, very important. Very, very important because it's not going to come in the exam, okay? 1/3 pi r squared times h. Next one we have is a triangular prism. This is easy because what you would notice is that the face is the triangle and then you multiply it by the height or the length here to find the volume. All right. Okay, so let's get into the questions. I want everybody got your calculator on hand. Even though you're not doing the question, I want to make sure you could type it in your calculator and get the same answer. Because I've noticed students having issues with that, especially for question number 6. So if you got your calculator close by and you're ready, say ready, and then we're going to jump straight into the questions. So this is supposed to be easy for everybody. Yeah. Just remind me about the YouTube link. As soon as class finish, I'm gonna download it and convert it. I just need a reminder to upload it tonight before I fall asleep. All right, so that's 4 persons, 5, waiting for everybody else to let me know that they're ready to go through the questions and they have the calculator. And let me say something now. If you don't have a calculator of your own, that's a problem. You have 3 weeks and a few days to familiarize yourself with a calculator for the exam. You should not be using any new calculator as of this week. You should know your calculator like the back of your hand. So you should know where your square buttons are. You should know where your square root buttons are, the sine, the cosine, the tan. You should know if you have the type of calculator, when you're typing something, it is given to you in a fraction. So you have to press a next button to turn it back into a decimal. Nobody should not have a calculator right now. I tell you now the truth. So if you don't have one, get together. Get together, get together, get together. All right, let's jump into it. So the first question says, find the area and perimeter of the shaded region shown below. Use pi is 22/7. You know why I like this question? The exam in January did this. They tell students you must use this version. So that's what we're going to do now. We're going to practice using pi because using it as a decimal is easy, right? So let's use it as a thing. Let's look at this image here. What do you notice about this image? When you look at it, they say that this is 7 and this is 7. But in your mind, does it look like they're equal? The two lines are equal? And I expect people to be responding quickly, eh? Does the two sides look, when you look at the picture, if you didn't read the image, does the two sides look like they're even, they're equal? That look like a square to you? It does not. Again, these are things CXC does. They give you images that don't match the actual values assigned to each side. So what is another thing you notice? What's another thing you notice? It got a piece of a shape inside the shape. What shape is that inside there? Think about, listen to the question again. There's two shapes here. There's a piece of one and a whole of one. Where I see the triangle? A triangle don't have any curved edges. This ain't a piece of a circle. Everybody check it and tell me if that ain't a piece of a circle. Now, this is the part I want you to pay attention to. Anybody know what fraction? It can be a semicircle. Does this look like half of a circle? This is a quarter of a circle. Imagine it. Imagine if I was to draw a line straight across. And this is the part what gets a little scary for me as a teacher. Like trying to get y'all to see certain things that not as easy to see. This in a quarter. Let's pretend that my circle look good, eh? Pretend my circle look good. Then a quarter of the circle. Everybody see that? How do I know without, if I didn't draw that, what is another way of identifying that it is a quarter? 90 degrees. If you got a circle, 90 degrees in a quarter of 360. May I want to laugh, yeah. Tyreek. Please. Thank you. So as I was saying, everybody see it though? So in future, if y'all ever see this, this represents that it would be a quarter of the circle. Everybody okay with that now? Everybody seen it now? Please let me know yes or no if you've seen it. And I realize me ain't hearing from some people anymore. I need everybody to let me know that they're locked in and they're paying attention. All right. So they say the shaded area. Anybody remember when you see a shaded area, what operation must come to mind? When you hear shaded area, based on what I was doing before, what operation you must end up doing? A, subtraction. Talk to me. Isn't it subtraction? So I'm going to show you an example. If I had a square and I had a triangle inside and I shade around the triangle and I say, okay, find the area of the shaded area. Wouldn't that mean I have to find the area of the overall shape first, which is the rectangle or the square? And then find the area of the triangle. And what am I going to do with both of them? Subtract. Everybody with me? You always take the bigger shape that outlines the area, the space, then the smaller shape that cutting out the space, and you subtract the two. So let's just make sure we're on the same page, please. Everybody with me? If you're not with me, just say no so I could fix it. Do you understand where we're going and why we're going? Okay, Leon said no. All right, let's try something here. I want us to look at an easy example. Before we look at a hard example, let's do an easy example. So everybody, I want you to try this question for me. This is a rectangle. Let's call this 10 centimeters. Let's call this 5 centimeters. Inside of that shape, there's another rectangle. And this one is 2 centimeters and 4 centimeters. There is a shaded area here. I'm going to use the green to kind of use to shade, right? Because, you know, it kind of had to like color. So let's use that to shade. Everybody find the area. All I want is the answer. What's the area of the shaded part, the green part? Everybody. Because there's no way we could do complex version of this question if y'all can't do this. So everybody do it for me now. Whether you do it on calculator, whether you do it in your book. What's the answer for the green part, the shaded area? Anybody? All right, trying? I hope so. I'm not moving on with class unless I see majority of persons share the answer. All right, so we got some answers coming in, and I don't even care if they're right or wrong. I just need answers. So I'm going to rate it so far. I'm going to rate what all options I have. I see 48. Hold on. I see 48 centimeters square. I see 50 centimeters, and I'm writing the units I send me. Eh? I see 8 centimeters square. I see 8 or 50. I want to know if you're going to do that in the exam. You got to choose one. Is it 8 or is it 50? And 8 or 50 what? Somebody said 8 centimeters square. Anybody else? Let's go. You are at a phase now where you're supposed to be able to produce your own solutions. All right, so let's take somebody say 42 centimeters. That's a different answer that I saw. Okay, so let's take a look. So step one, keeping in mind for you to get the answer right, you must have the correct working answer units. So let's go. I want the shaded area here. The shaded area here ain't everything except this piece in the middle. Is like a donut. Y'all see what I mean? It's like a donut. Y'all know that, right? You see what donut look? With a hole in the middle? So for you to find the area that's left back after you take out the hole in the center, that means you find the area of the big shape and you subtract the area of the small shape. So what is the area of the big shape? The area of the big shape would be 10 times 5. So to get all your marks, you put 10 centimeters times 5 centimeters minus the area of the small shape, which is 2 centimeters times 4 centimeters. So that would give me 50 centimeters square minus 8 centimeters square. So the answer is 42 sorry, centimeters square. For those who didn't get it right, how I get 8? Big man thing, tell me, how I get 8? I only find the area for this the center. I didn't ask for the area of the center. I asked for the area in the green. Everybody see what I'm saying? Everybody with me now? Before we go to the harder concept? Talk to me now, because this is what we're trying to fix. Think about it like a donut. A donut, if somebody was to, you see how Rituals has got the two type of donuts? They got the ones with the hole, like the regular one, and then they got the kind of square ones that ain't on a hole. You gotta think about the one with the hole. The one with the hole is missing the middle. So you got to subtract out the part that's missing. So if you want the area of the donut, you just got to find the area outside of the center, which is why you subtract. So I hope everybody understand the concept now so that I could explain this version of the question now. All right. So think about this now like a cake, a square cake. And somebody say, well, I wanted my piece of my cake to be kind of circular. So they kind of cut out a piece. And then this is the part that left back. Everybody understand how we will go about finding this part that's left back? Left back is done after you do what? Subtract. So what you would have to do first is find the area of the overall cake by the square pan. Then find the area of the circular part, that is what you take out, which would give us what is left back, which is the shaded area. If you got it, say got it, because I can't do nothing else if you ain't understand that part. That's 2 persons, that's 3, 5. Are watching the chat. And this is the easier versions, guys. So just let me know it can get a little bit more challenging as we move forward, but just try to keep following. That's all I want. Y'all understand and follow. Okay, so let's go, guys. So we do agree that there's always a bigger shape and a smaller shape, right? The formula is always the same. You want a shaded piece, you look at the bigger shape and you subtract the smaller shape that's coming out. So that's the first thing I'm going to write. Shaded area is equal to big shape. Sorry. Big shape minus small shape. Okay, so I hope everybody here with me. So we're gonna take it slow. No, because it's area, remember all of it is area, area, area. So you know what formulas we gotta use, right? Because the big shape, what is the big shape? The big shape is a square. So that would mean 7 times, let's use formulas just to make sure we understand. Because this is a square, that's L square. Everybody with me? Why is L square? Because the length and the width is the same thing. So that's why it's length times length. Minus the small shape. And the small shape, what did we agree about the small shape? The small shape is a quarter of the entire circle. Agreed? I know I'm moving fast, but I want to make sure y'all still with me. Agreed? That the area of this part here is a quarter of the overall shape. So all you have to do is write what the formula is for the overall shape. And that's because it's a circle, that would be pi r square. But we don't want the whole circle. We want a quarter of the circle. So how do we get a quarter of something? We divide it into how much? We divide it into 4. So let's pause right here and let me know. If you got how I got this, if you understand how we get this formula, say got it, please. I'm watching the chat, I'm watching the chat, I'm watching the chat, I'm watching the chat, I'm watching the chat. Now, let's take a look at this working here to make sure we understand. I don't like how they did this working here, so I can do it myself, right? So let's go. This part is easy. Why is this easy? Because this is just 7 square, which is 7 times 7, right? Minus pi r square. Anybody could tell me the value of r from this diagram? Let's see who could really figure out these things, because that's the trick about passing, huh? What number would represent r, which is the radius of the circle? Okay, Tyreek says 7. Anybody else want to try? Do you agree with him? Do you think it's something else you don't know? Talk to me. Excellent job, guys. Very good. Because obviously, if this is a quarter, this is the center. If this is the center, that means this distance is the radius, and this distance is the radius. Excellent job, guys. Excellent. So we're going to end up with pi 7 square divided by 4. Everybody see that? We see we're matching? No, I'm gonna be honest with you. Let me explain something. Let's say the exam say use a specific thing, but you think it gonna throw you off or you gonna get confused. Use what you know. Because guess what, you gonna get your mark still. You might just lose like a half mark or a mark. Everybody see what I'm trying to say? You know what pi is. Let's say you don't want to use 22/7 because it's confusing. I'm gonna show you how to use it still, but I'm just saying. Everybody with me? So let's work out this using the regular way, which is using decimal, or let's just use the fraction. 7 times 7 is 49. Minus, they say use pi is, what they say pi is again? 22/7. So yeah, I have 22/7 times 7 square over 4. How would you work out this? Can this be cancelled? Can anything be cancelled? This is a serious question, all right? Go back 49. Anything can get cancelled here? Yeah, because 7 can go into itself once. And if I take out 1 7, that gone, so just 1 7 left, right? What's another thing that left back? 2 can go into itself. 2 can go into 4 twice. And 2 can go into 22 11 times. So what you're going to end up with is 77/2. So you have 49 minus 77/2. Somebody calculator, please. Tell me where you get. That's what your calculator give you. 49 minus 77/2, 33/2. Yeah, you're supposed to get 10.5. Look at you. You see where we gotta work it out together, please. Everybody, make sure you get 10.5, please. Make sure you get 10.5 because I'm gonna tell you the truth. You see, things like this, you gotta be able to finish on your own. I don't know how you get 33. Try again, try again. Everybody else, let's go. Make sure you get 10.5, 10.5. If you got it, excellent. All right, next shape. Next question. Okay. Figure A represents the floor plan of a room in a building. The owner is planning to buy floor tiles to cover the room. Now, this question is easy. How many tiles? Oh God, look, this is a whole stress now. Watch this. They got 2 different tiles. They got tiles where you have 25 centimeters costing 25.60 each. And then they have a bigger size, which is twice the size. They have 50 centimeters costing $90 each. Which option would you choose and why? How are we gonna do this? Anybody know how to start this off? Anybody know what they would do first? Let's discuss that because it ain't make no sense start calculating if you know what to do. You have a room that you got to tile. When you're going to buy the tiles, they got 2 options. How would you determine which buy is the better buy? What would be the first thing you need to work out? I'm not telling y'all what to do. Y'all got to this. We have to discuss this because this is what we're talking about, reading comprehension. Somebody say, okay, somebody just message me directly and they say something. Let's go. Anybody else? Okay, but how do you determine the amount of tiles needed? That can't be the first thing that that can't be the first thing that you find. Because what would tell you how much tiles you need? This is why we're discussing it. Joe, size of what? You can't just say size and amount of. What are you talking about? Find the length, but they gave us the length. You sure it's the length that you need? The perimeter, remember the perimeter is the area around. You want tiles, you want cover the floor. What do you need? What information you need about how much coverage the floor has? Area of the floor. Everybody with me now? So let's stop here because that's where we gotta work on the reading and understand. Think about is like it's your house. How would you go about knowing how much tiles to buy if you don't know how much space you have to cover? Everybody with me? Stop thinking about it like a question and put yourself in the situation. What would you do? So we need to find the area. How do I find the area of this shape? Can I just say length times width here? Or I gotta bust it up. This is primary school now, eh? Find the area of this shape is primary school. So how do we do it? Would you say half? Is it actually half? Or you gotta separate it into two different shapes? You gotta bust it up. So let's bust it up coming down. What color is that? Blue? Let me use green. Let's bust it up coming down. How much shapes can I find now? They say in two shapes, shape A and shape B. So all you have to do is find the area of A, find the area of B, and what you gonna do with both of them, peoples? To find the overall area. What do you do with both of them? Multiply, you sure? If I want to find the total area, add, right? Remember, you want to put them together. So because you're putting them together, you're gonna add, okay? You with me? All right. All I want is answer. What's the area of A? Anybody? Somebody? What two numbers you're going to use? This is interesting. I just want the answer. It shouldn't take 40 years. Was the answer awaiting? I see 6 people. I asked for the area, not the dimensions. Area was the answer. Or watching the chat. Anybody else trying? The answer is 6. Because look at A. What's the length and width of A only? 2 times 3. So that's 6 centimeters, 6 meters square. Plus B. What's B? What's the area of B? We gotta pay attention to dimensions. Check again. Look at B. What's the length and the width of B only? Look at where B start and stop. So which two numbers are gonna use for B? I would use 4 and I would use 3. So that would give me 12. So what's the overall area of this shape? The overall area of this shape would be what? We're gonna do with the 6 and 12 again. 18, excellent, 18 meters square. So now that we have how much tiles we need to cover, guess what makes this situation hard? Anybody could tell me what makes this situation hard? What is the dimensions of the tiles? Did they give us the dimension in meters? No. They gave us the dimension in what? So everybody realize what coming to mind now? What do you have to do? I can't divide two different measurements. They must be in the same measurements. Agreed? So somebody got to get converted. So what we're going to do is convert. No, because you have to measure the room. So you got to convert the tiles into what? Meters. How do I convert 25 centimeters into meters? I got to do what? Divide by 100. Because everybody should know the conversion cloud. Let me just draw that quickly there, see? You start off with the smallest one, millimeters, centimeters, meters, kilometers. From here to here is a kilo is 1,000. Centi is 100. Look at the direction of the arrows. Meters is times 10. And to go the opposite way, you got to divide. So from here to here is divided by 10. From here to here is divided by 100. And from here to here is divided by 1,000. Right? So basically, that means 25 centimeters divided by 100. That would now become 0.25 meters. And then what is this? What this become? 50 centimeters would therefore become 0.50 centimeters. Everybody with me? Now, how would we determine how much tiles we get now? What we gonna do with these numbers? So we got these numbers here. 18 meters square is the room. Tile 1 is 0.25 meters. Tile 2 square is 0.5. What are we going to do with these two numbers now? How do I know how much I need? Add. Think about it like I have a class and I need to share pizza. What operation I going to use to share the pizza to determine how much slices I need? May and divide how much people, the pizza into how much people in the class. You see what I mean? We gotta think along them lines. Even if you don't remember what to do in this moment, think about the next situation. How do you determine how much to share something? You divide, right? So which two numbers we divide in first? We gotta take the room and divide by tile 1. So I'm gonna just use the examples here since they have it here. We watching? Everybody watching? Where's option 1? No, here's what. Why we can't just divide by 0.25? Why we just can't divide this? I made a mistake and I put square. Is that true? No, because they didn't give us the area of the tile. They gave us the length. So you see, I even made a mistake here by assuming that it was the area. They didn't give us the area of the tile. They gave us the length of one side. Everybody with me? And what type of shape is that? A square. So let's follow the workings here to make sure we understand. So the first thing that they did was find the area of one tile in meters square. So that's why they have 0.25 times 0.25. This is the answer for the area of one tile for option 1. Now, this is the number they're going to use to divide because you got to divide area by area. And when they did that, this is how much tiles they got, 288 tiles. So if you need 288 tiles, how much for each one of them? 2560. So you multiply 288 by 2560, and that's how much it costs. $7,372.80. Let's look at option 2. The length of one side is 0.5, so they multiplied 0.5 times 0.5, and that's how much the area for one of the bigger tiles is. And then they divide, but this only need 72 tiles. 72 times $90 because one of them big tiles is $90 and this came up to 6,480. What does that mean? Who is the cheaper buy? Option 2 is the cheaper buy. If you understand what we did here, just say got it. Let's keep it moving. We can do one more. Or watching the chat, or watching the chat, or watching the chat. All we're doing is going through. So you see how they did this here? This is exactly how the exam question gonna come. A real life situation gonna happen. They're not gonna give you no shape and find this. No, it's gonna require you to do a lot of thinking and a lot of calculation outside of the topic itself. Okay. All right. So let's look at this one. What this one asks for. The diagram not drawn to scale shows a prism. Calculate the area of the cross section. This is easy. We can run through this quick. This ain't even a real life situation because if it was real, this is what CXC would do. And I had a whole lot ahead. They would be like, oh, this is the shape of the tank of water that stores during the drought. And they're going to say, oh, the water is at a height. And they're going to tell you the height of the water. And then they're going to say how much more water is needed to fill it up. That's a CXC question, to be honest with you. But let's see what they gave us here. We'll just run through it to make sure we understand, right? They ask for the area of the cross-section in centimeters square. We know what cross-section means. Cross-section means just the face. So you look at the shape of the face, and the shape of the face is a trapezium. So you know the formula for that, half A plus B times H. How do we know this? This is on the formula sheet, so we're good to go. Then they ask for the volume. You should always remember volume is equal to the area of the cross-section times the height. Anybody could tell me what's the height? What number represents the height here? Let's see if you really learn anything tonight. What number represents the height of that shape? Excellent job, everybody. Excellent job. Excellent job. Very good. Honestly, thank you, Jesus. Very, very good. That's exactly why I took the time out earlier to explain. So when we get here, that's exactly what I expected to see. Everybody understand what, when I say height, what I'm talking about. Excellent. Next question, the surface area. Everybody know what I mean by the surface area? Based on what we explained? That means you have to find the face for everything, right? The only thing that's different about this is that all the shapes doesn't match, right? Do you agree? So this front would match the back. I just drawing it so you can see. This front gonna match the back. But all the other sides, what shape all the other sides got? Look at the top. What shape the top got? The top is what shape? Very good. Everybody seen it? Let me just erase this so I could draw the lines then better. So I'm gonna draw, because this is what I need y'all to make sure y'all see and understand. Okay, I bring this down too much, sorry. Let me just bring this down a little bit. That should be good. Yeah, I'm looking like it, ain't? Good. So the top is a rectangle, and what numbers you would use to find the area of the top? Wayne, what can you tell? I just want you to make sure you understand. What two numbers you would use for the top? Look at it good. Look at the top. What numbers you would use for the top? Let's see who could see properly. Anybody. You could even share one. If you're confident about one side, excellent. That's one side, 10. Excellent, 10 and 45. Yup, it's 10 and 45. Because why? If here and here is 45, here and here ain't 45, and that means here and here is 45. All these lines going back will be 45. 45, 45, 45. I hope you're seeing it. Seen it? Excellent, that's the top. Which numbers you would use for the back, in the back here? The back of the trapezium. What would you use? Which two numbers you would use for the back of the trapezium? 8 is correct. That's an 8 or a 6? I ain't even know. It's a 6. 6 and what? Let me zoom in more. We're looking for the back, this back piece here. So 6 and what? Not 10. And 45, look at it. This line, look at it. And this back line here, these two lines here. Everybody seeing it now? So it would be the 6, and the 45. Yeah? What about the slanted front? Which two numbers you would use for the slanted front? Mm-mm, mm-mm. When I say the slanted front, I mean this in front here. Thank you. 10 and 45. And the last one is the base. What you would use for the base? Look at the bottom. Look at it. The base of the shape. What would you use for the bottom? What numbers you would use for the bottom? 18, yes. Yes. 18 and what? Excellent. 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 Very good. So guess what? Once you find each area of each shape, what do you do with it? You add it up. That's it. This is what I want us to touch on because this come a lot. This whole drum container. Um, yeah. But let me just pause here for a minute. Has everything we've done before been okay though? Like as in you guys were able to follow? Because that's what we're trying to gain right now. Understanding and following. Okay. I just want to expose you to questions. So if you see questions, you kind of have an idea of how to approach it. Let me just go over here. So here's what we'll do then. What time it is? We're gonna take a break because I don't want to start another question under these conditions. So let's take a 10-minute break so that we could kind of let what we did settle because it don't make sense to try push 3 hours straight, just like in regular class. So let's come back at 7 o'clock. And what I'll do is we only got these, I'll finish these 3 questions at 7. So this one, because this question has come a lot when you have a semicircle drum. I think they say like this whole like a barbecue pit. And then this one has come a lot with the container with water. Remember we was talking about that? And then we did something like this before, but I want us to actually work it out. So we're gonna take a break now. Oh, I have to do this cone. I have to do this cone. I have to do this cone. So yeah, let's take a break and we come back at 7. Okay, guys, so let's finish strong. Hopefully y'all are still alive. Let me know if y'all want to continue. Y'all want to continue. Y'all want to stop here and continue tomorrow. Let me know if y'all are still willing to continue. Let me send a text message to everybody. Let's send a message to tell everybody that we're ready. Yeah, a few persons are responding directly. Let me know, let me know, let me know. I have 2 for continue, 1 for continue tomorrow, majority rules. So I just need feedback. Okay, 3 for continue, 2 for tomorrow. When you say same to who? Continue tomorrow? Tomorrow? Okay. Because we did a lot. We did a lot. I'm not gonna lie, we did a lot. All right, so tomorrow, since we have class tomorrow, we're gonna continue the other questions tomorrow and then go into the exam questions, okay? So for those who have the notes, you could look at the questions, practice, but keep putting in the work. Okay, guys, proud of you. See you tomorrow, same time. I'm gonna send the link. Bye.